Welcome back to PPV. In this video, we are going to look at BCNF, one of the higher normalization forms. Please watch 1NF, 2NF, 3NF videos before you come here, or else BCNF may sound a little bit complicated. But if you have a proper foundation on normalization forms, BCNF will be easy for you to understand. Oh, I didn't say what BCNF is. BCNF means Boyce-Codd Normalization Form. Okay, Boyce-Codd normalized form or normalization form. So let's dive right in. BCNF. Well, BCNF is really closely related to 3NF. Okay, it is very closely related to 3NF, and still 3NF has some loopholes in it. Okay, 3NF has some loopholes in it. Therefore, we have BCNF to rectify them. Okay, we have BCNF to rectify the loopholes in these 3NF. That is why we have BCNF. And we don't talk about this much because normally the tables which are in 3NF are already in BCNF. Okay, so normally this is what happens. But sometimes in rare cases, all right, in rare cases, there might be issue with 3NF that you can't treat with 1NF or 2NF. You can't do that. So you have BCNF to take care of those mistakes. All right. So I'll explain the rule for BCNF. Here we don't have to talk about the practical rule definition, formal definition, characteristic and all. We can directly go and understand what actually BCNF means, because BCNF is directed towards only a single problem that we are going to focus. So let's talk about that. So a relation schema R is in BCNF if for every non-trivial functional dependency, non-trivial functional dependency, X functionally determines A, X is a superkey of R. X is a superkey of R. Well, if you look at this without any understanding, you wouldn't understand anything. Okay. If you don't know what non-trivial functional dependencies are, or if you don't know what superkeys are, you won't understand anything. Okay. You will be like, what's going on here? Okay. So I'll explain it. First of all, I'll explain what these two terms mean. Okay. And then we can come to an understanding about BCNF that we can use to do some questions. All right. Yes. So first of all, non-trivial functional dependency. Well, first of all, we'll talk about trivial functional dependency. If we don't know about trivial functional dependency, how can we talk about non-trivial functional dependency? So let's talk about trivial functional dependency. Okay. So trivial functional dependency means we can simply say the obvious functional dependencies. Obvious functional dependencies. Obvious FDs. What do I mean by that? Well, if A is a subset of X, we can say X functionally determines A. We can say this. This is what we call in Armstrong's axiom the reflexivity axiom. Axiom. Okay. So these are some obvious FTs. Okay. And since we know X will be a subset of X, we can say X functionally determines X. Okay. So this is what we call trivial functional dependency. Okay. So the dependencies in between subsets and their supersets. Okay. So what is a subset? Well, let's say if A is equals to B, C, D, and let's say X is equals to A, E. Well, here we can say A is a subset of X. So X functionally determines A. This is a trivial dependency. It's a trivial functional dependency. If, okay, let's say we have another one. Let's say there is another set of attributes called F. And if you say X functionally determines F, well, this one is special. Why? This one is what we call non-trivial dependency. This is what we call non-trivial dependency. Non-trivial functional dependency. Non-trivial functional dependency. Okay. So when we don't have the subsets, okay, a functional dependency, what is a non-trivial functional dependency? A function, an FD, where A is not a subset of X, and X functionally determines A. What does this mean? A is not a subset of X, or you can say X is not a superset of A. X is not a superset of A. Superset of A. What is a superset? Well, here A is a subset of X, so we can say X is a superset of A. X has other elements also in its set, but we can say we can say X is a superset of A. Okay. So what about this? Is X superset of B? Yes, obviously. Why? X is a superset of A, and A is a superset of B. So we can say X is a superset of B, and you can say B is a subset of X. Okay, you can't say equal to, because it can be equal to, yeah. So you can say this. So this is what we call trivial functional dependency. The trivial functional dependency is when you apply reflexivity from Armstrong's axiom. And if you have a functional dependency where X functionally determines A, and A is not a subset of X, well, then you can say this is a non-trivial functional dependency. Now let's talk about superkeys. So what is a superkey? Well, superkey is a combination of two things. It's a combination of first thing, candidate key. Candidate key. It's a combination of candidate key. Well, what is a candidate key? We have already talked about that. An attribute or a set of attributes that can uniquely identify a tuple in a relation. This is what we call a candidate key. Primary key is selected from candidate key. Okay, so you choose the candidate key is there. The candidate key is there. You will choose the primary key. So there will be candidate keys. Let's say there are candidate keys. You will choose the primary key from the candidate key. And other candidate keys, the remaining candidate keys are called alternative keys. Or you can say alternate keys. So this is how it works. It's like having employee ID and their social security number, the NIC number, national identity card number together. Okay, it's like that. So keep that in mind. Now let's talk about the second one, combination of candidate key or a superset of candidate key. Superset of candidate key. I have already talked about superset. If X is equals to A comma B, and A is equals to C comma D, Okay, you can say X is a superset of A. And similarly, superset of candidate key means, let's say, candidate key in a let's say there is a relation called student student relation, and we know student ID is a candidate key. Student ID is a candidate key. We can say student ID functionally determines student age. We can say that. Then naturally we can say student ID, comma, student name functionally determines student age. We can say that even though it's a partial functional dependency, we can say if student ID functionally determines student age, comma, student name can also functionally determine student age. This is an example for candidate key, and this is a superset of candidate key. This is a superset of candidate key. So this is what we call super key. This is what we call super key. Super key is the combination of candidate key and supersets of candidate key. Okay, now let's come back to the definition of BCNF. A relational schema R is in BCNF if for every non-trivial functional dependency, X functionally determines A, X is a superkey of R. X is a superkey of R. Okay, this is very important. This is what we call the BCNF condition. Okay, this is what we call a BCNF condition. Keep that in mind. Keep that in mind. Okay, so X has to be a superkey. X has to be a candidate key or part of candidate key. Whether we like it or not, that is the BCNF. And in BCNF, the problem is sometimes you may not be able to preserve the functional dependencies in the table. Okay, you may not be able to preserve the functional dependencies of the relation. Okay, we know, obviously we studied that in decomposition, we should make sure that we preserve two things. One is data integrity, second one is the functional dependencies. Data integrity is preserved when the lossless join condition is satisfied, and we have to satisfy we have to preserve functional dependencies. And how do we do that? The functional dependencies in all the relations. Okay, so if you have some functional dependencies in the relation, okay, the big relation, if you have functional dependencies, let's say A, B, C functional dependencies, if you break it into three relations, the functional dependencies in these three relations should represent A, B, C. They should cover A, B, C functional dependency. But when you do BCNF, when you decompose to BCNF form, well, the unfortunate happens, and you may not be able to preserve FTs.
Thanks for watching the 18th video in our normalization series. If you found this breakdown of Boyce-Codd Normal Form helpful, don't forget to like, share, and subscribe for more database tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master all normal forms. And I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.